Hello everyone and God bless. In this session we're going to learn about how to evaluate the derivative of a function based on the theorem of derivation, which is the limit of f of x plus h minus f of x divided by h. As h approaches 0, we're going to understand how it works. So what is the derivative or a differential of a function? It is the slope of the tangent against the curve, or the tangent theta, where theta is the angle formed by the tangent against the curve and the horizon, or the line parallel to the x-axis. So here, if you notice that the angle is negative, hence it means tan theta would be negative, of course, and the curve would be descending, which is indicated by the direction of the tangent against the curve, that is descending. Meanwhile, if you have a positive angle, so tan theta would be positive, and the line would be going up, so the angle would be positive, the line would be something like that, okay? So this is a positive slope, and the angle with the horizon would be a positive angle, which means that at such point, the tangent or the curve would be ascending. So here you notice that the curve, which is the blue one, is increasing. It is rising. Now, how to evaluate this derivative? F prime of x, or the slope of the tangent, is equal to the rise over run, meaning that how much is the curve ascending or descending in respect or in comparison with the distance being traveled, okay, during that rise or descent. So here you notice to the left we have x plus h and x. Okay, so starting at point x, you get a step ahead of x plus h, which is right after x. Okay, x plus h is at a very small distance from x. And okay, so this is the run, or the horizontal distance traveled. Now the rise is fx plus h minus f of x. So f prime of x, in other words, it is delta y over delta x. What is delta y? It is fx plus h minus f of x. So it is this distance. This is delta y divided by delta x, which is the run, or divided by x plus h minus x, or simply divided by h. Here's another thing to pay attention to. It is actually the limit of that quotient as h approaches 0, meaning that h should be a very small number. So the step between x and x plus h should be a very small distance, so as to get an accurate result for the tangent, for the elevation of the tangent at that specific point x. As a first practice, find the derivative of f of x is equal to x squared, of course based on the theorem of derivation, which is through the limit of f of x plus h minus f of x divided by h. So f prime of x is equal to limit as h approaches 0 of fx plus h minus f of x divided by h, equal fx plus h, so you replace x with x plus h here, squared, because x is squared, minus f of x, which is x squared, divided by h. Okay? Always remember that it is the limit as h approaches 0. Okay? But so as we don't repeat ourselves, we will solve it and finally place the limit. Equal to, let's develop, x squared plus 2hx plus h squared minus x squared divided by h, equal, so x squared minus x squared is eliminated. We are left with 2hx plus h squared divided by h, equal we can break them down into, okay, 2hx over h plus h squared over h, which is h. Now, we can factor out h in the numerator and denominator, so we are left with 2x plus h. What is the limit of 2x plus h as h approaches 0? H becomes 0, and we are left with 2x. And this is the derivative. So the real derivative of f of x is 2x. And as we evaluate the limit, 2x is considered as if it was a constant. Find the derivative of f of x is equal to x to the power of 3. Okay, so limit as h approaches 0, or f prime of x, is the limit as h approaches 0 of f of x plus h minus f of x divided by h equal limit as h approaches 0. Okay, f of x plus h is x plus h to the power of 3 minus f of x, which is x3, divided by h equal limit as h approaches 0. Okay, so x plus h to the power of 3 is x3 plus 3x squared h plus 3x h squared plus h3, and we are left with minus x3 divided by h. In case you're wondering, this is the formula. Okay, x plus h to the power of 3 is like a plus b to the power of 3. It is equal to a3 plus 3a squared b plus 3ab squared plus b3, instead of, going all the way in evaluating s plus x plus h squared, then to multiply it with x plus h. Okay, so it is the limit as h approaches 0 of x3 plus 3x squared h plus 3x h squared plus h3 minus x3 divided by h. Now, x3 minus x3 cancels out. We are left with limit as h approaches 0 of 3x squared h over h. We're gonna divide them, like separate different quotients, plus 3x h squared divided by h plus h3 divided by h equal limit as h approaches 0 of 3x squared times h over h. This becomes 3x squared plus 3x h, because h squared divided by h, okay, plus h squared. So limit as h approaches 0 of 3x squared plus 3xh plus h squared. As h approaches 0, 3xh becomes 0, h squared becomes 0, and we are left with 3x squared, which is the answer for the derivative of f of x equal x3. Find the derivative of f of x equal sine x. So, again, f prime of x is equal to limit h approaches 0, f of x plus h minus f of x divided by h. So, equal to limit as h approaches 0, sine x plus h minus sine x divided by h. Okay. Now, referring back to the trigonometric relationships, or identities rather, we know that sine a plus b is equal to sine a cosine b plus cosine a sine b. Remember, for the sine, plus remains plus on the outside, minus remains minus on the outside, and it pairs with the other kind, meaning that sine a plus b is equal to sine a cosine b plus cosine a sine b. So sine with cosine, and cosine with sine. Meanwhile, for the cosine A plus B, for example, the plus becomes minus on the outside and the minus becomes plus. So you invert everything. And cosine pairs with cosine, also sine, meaning that cosine A, cosine B, cosine A plus B becomes cosine A, cosine B minus sine A, sine B. Cosine with cosine and sine with sine. And the plus becomes inverted to minus and vice versa. So f prime of x is equal to limit as h approaches 0. Let's develop sine x plus h. It becomes sine x cosine h plus cosine x sine h. Then we still have minus sine x in the numerator divided by h equal. Now, as h approaches 0, cosine h becomes 1 because it becomes cosine 0, which is 1. So it's equal to limit sine x plus cosine x sine h minus sine x divided by h. Now, you might be wondering, okay, what about the sine h here, right? So, yes, cosine h, as h approaches 0, cosine h becomes 1, becomes cosine 0. However, for the sine h here, we cannot get rid of it. I'll tell you why. Because, yes, as h approaches 0, sine h becomes 0. However, you have 0 in the denominator. So how to get rid of it? Because the limit becomes 0 over 0, which is undetermined. We cannot have that. So let's check what we can do. Now, okay, so for cosine h here, it becomes 1. Yes, but notice something. We have sine x and minus sine x. They cancel out. So we are left with limit as h approaches 0, cosine x sine h divided by h. Now notice something. We know that as h approaches 0, when h becomes very small, sine h approaches h, meaning that sine h over h becomes 1. Isn't that right? So this is the theorem of the sinus. So if you have sine a divided by a, it approaches 1. Sine a becomes equal to a as a becomes very small, as a approaches 0. So the limit is equal to, for sine h divided by h, okay, it's equal to 1, and we are left with cosine x. So the answer is cosine x, which is correct. The derivative of sine x is equal to cosine x. Find the derivative of f of x equal cosine 3x plus 1. Okay, so limit as h approaches 0, fx plus h minus fx divided by h. Let's keep this formula in mind. Hence, f prime of x is equal to limit as h approaches 0. fx plus h is cosine of 3 times x plus h plus 1 minus f of x minus cosine 3x plus 1 divided by h equal limit as h approaches 0 of cosine 3x plus 3h plus 1 minus cosine 3x plus 1 divided by h. We can separate for the first one the cosine 3x plus 3h plus 1. Actually, we can make it, okay, cosine 3x plus 1 plus 3h, where this part is a and this part is b, and solve it based on the trigonometric identities. So we know that cosine a plus b is equal to cosine a cosine b minus sine a sine b. Remember that for the cosine, you always flip the sign. So if it's positive, it becomes negative on the outside, and vice versa. If it's negative, it becomes positive. And you pair cosine with cosine and sine with sine. So for cosine 3x plus 1 plus 3h, it becomes cosine 3x plus 1 times cosine 3h minus sine 3x plus 1 times sine 3h. We place them back in the limit, so it is limit as h approaches 0, cosine 3x plus 1 times cosine 3h minus sine 3x plus 1 times sine 3h minus cosine 3x plus 1 divided by h. Let's erase a little bit, okay, on the above lines to make it a little bit more neat. Now, as h approaches 0, cosine 3h becomes 1. Okay, cosine 0 becomes 1. So the limit becomes, as h approaches 0, cosine 3x plus 1, with cosine 3h having become 1, because as h approaches 0, cosine 0 is equal to 1, minus sine 3x plus 1 multiplied by sine 3h minus cosine 3x plus 1 divided by h. Remember, we need to get rid of h, right? So, first, cosine 3x plus 1 minus cosine 3x plus 1 becomes 0. As for, if we make sine 3h as h approaches 0 is equal to 0, but we have 0 in the denominator, 0 over 0 is undetermined. So we need to get rid of it. Hence, okay, so how to get rid of it? Remember that if a approaches 0, whatever a is, then sine a approaches a. So sine a divided by a becomes 1. But here you have sine 3h. We need an equivalent quantity in the denominator for this quotient to become 1. So a trick to do that is by multiplying in the denominator and the numerator by 3. Let's multiply by 3 both in the numerator and the denominator. Limit as h approaches 0 of minus 3 sine 3x plus 1 sine 3h divided by 3h. We multiplied both numerator and the denominator. As h approaches 0, sine 3h approaches 3h. So this quotient becomes 1. And we are left with minus 3 sine 3x plus 1. That's the final answer. Fx equal x divided by x minus 3. Limit as h approaches 0, fx plus h minus fx divided by h. Okay, so it is the limit as h approaches 0. Fx plus h is equal to, okay, you replace x with x plus h divided by x plus h minus 3 minus x divided by x minus 3, this is f of x, over h, equal, let's establish a common denominator in the numerator in the first part here above. So x plus h minus 3 times x minus 3. So you multiply by x minus 3 here to the left. So it is x plus h times x minus 3 minus x multiplied by x plus h minus 3 divided by h, equal limit as h approaches 0. Okay, x plus h times x minus 3, it is x squared minus 3x plus hx minus 3h minus x squared minus xh plus 3x divided by, okay, here h we can multiply it okay, immediately in this denominator. So it is h multiplied by x squared minus 3x plus hx minus 3h minus 3x plus 9. Okay, we are multiplying these two here, these two parts. Now, 3x minus 3x cancel out. hx minus hx cancel out. And also x squared and minus x squared and plus x squared cancel out. We are left with minus 3h divided by h times x squared minus 3x plus hx all the way. Okay, so equal to limit as h approaches 0 of minus 3h divided by h multiplied by x squared minus 3x plus hx minus 3h minus 3x plus 9. Okay, so yeah, h cancels out and we are left, let me place it here, it would be more neat. Okay, limit of minus 3 divided by, so h has been factored out from the numerator and the denominator, and I'm copying this part in case to the right you cannot see it. So of x squared minus 3x plus hx minus 3h minus 3x plus 9 as h approaches 0. Now, as h approaches 0, hx minus 3h cancel out. We are left with minus 3 divided by x squared minus 6x plus 9, which is simply what? It is minus 3 divided by x minus 3 squared. This is the answer, from which we have the formula u prime v minus uv prime divided by v squared, where u is the numerator and v is the denominator. This is the derivative of a quotient. Another one like it, so f of x is equal to x squared minus 1 divided by x plus 2. Okay, f prime of x is equal to limit as h approaches 0, x plus h squared, we replace x with x plus h, minus 1 divided by x plus h plus 2 minus f of x, which is x squared minus 1 divided by x plus 2, all divided by h. Equal, we establish a common denominator in the above, so x plus h plus 2 times x plus 2. Okay, so to the left we multiply by x plus 2, so x squared plus 2hx plus h squared minus 1 times x plus 2 minus x squared minus 1 multiplied by x plus h plus 2. Okay, x plus h plus 2 over x plus h plus 2 times x plus 2. By the way, this h can also be removed and multiplied here right away. Let's keep developing. So limit as h approaches 0 of, so x squared times x, it is x3 plus 2x squared plus 2hx squared plus 4hx plus h squared x plus 2h squared minus x minus 2. Then you have minus this part, okay, this part here. Okay, so it is x3 plus x squared h plus x3 plus x square h plus 2x square minus x minus h minus 2. I understand it's a long calculation. So in the denominator, so x squared plus 2x plus hx plus 2h plus 2x plus 4. So limit h approaches 0. x3 plus 2x squared, I'm just copying, plus 2hx squared plus 4hx plus h squared x plus 2h squared minus x minus 2 minus x3 minus x squared h minus 2x squared plus x plus h plus 2 divided by h times x squared. Okay, plus 2x is 4x plus hx plus 2h plus 4. Now let us factor out. So you have x3 and minus x3. And yeah, 2x squared and minus 2x squared, 2x squared and minus 2x squared. Then plus x minus x minus 2 plus 2. Okay, so you have, yeah. Okay, so all what is left has an h multiplying it, so we can factor out h and h. Okay, let me make it a little bit cleaner. So limit as h approaches 0 of 2hx squared plus 4hx plus h squared x plus 2h squared minus x squared h plus h divided by h times x squared plus 4x plus 4 plus hx plus 2h. I removed the 4 to the left. Okay, h can be factored out, so because you have h multiplying all the numerator and you have h here, so limit h approaching 0 of 2x squared plus 4x plus hx plus 2h minus x squared plus 1 divided by x squared plus 4x plus 4 plus hx plus 2h. Now, as h approaches 0, this one becomes 0, this one becomes 0, this one 0, this one 0. Okay, so we are left with 2x squared minus x squared is x squared plus 4x plus 1 divided by, what is x squared plus 4x plus 4? It is x plus 2 squared. And this is the final answer. Let's verify this derivation based on the formula that we know. If u is equal to x squared minus 1 and v equal x plus 2, so the derivative of u over v is equal to u prime v minus u v prime divided by v squared, which is u prime times v is 2x times x plus 2 minus u x squared minus 1. V prime is 1, derivative of x plus 2 divided by v squared, which is x plus 2 squared, equal 2x squared plus 4x minus x squared plus 1 over x plus 2 squared, or v squared, which is x squared plus 4x plus 1 over x plus 2 squared. The same result we obtained using the derivation formula, or rather the law of derivation, so to speak, which is rooted in evaluating the limit as h approaching 0, the formula that we've been seeing so far. Now here, this one is a little bit tricky. So f of x equal ln x. Okay, so x divided by h. Let's find that out. So it is the limit as h approaches 0. F of x plus h is ln x plus h minus ln x over h. Now, we know based on the formulas of the logarithm that ln a over b is equal to ln a minus ln b. So, this one can be rewritten in the numerator as ln x plus h divided by x over h. So also can be rewritten as, since it is divided by h, as 1 over h times ln x plus h over x. So 1 over h can be moved to the power, right? Because you know that a ln b can be written as ln b to the power of a, right? So this is equal to limit as h approaches 0, ln. Let us factor out actually, and decompose this quotient. So it is ln x over x plus h over x to the power of 1 over h equal, okay, to limit h approaches 0 of ln x over x is 1 plus h over x to the power of 1 over h. Now, as a note or a reminder for those who already know that, 1 plus u to the power of 1 over u is equal to the exponential. Okay, so again, 1 plus u or 1 plus something to the power of 1 over something is equal to e, which is the exponential. Hence, okay, so you have 1 plus something, right, which is h over x. If it's like to the power of 1 over something, which would be the inverse of h over x. So, in other words, it would be x over h. That would become the exponential. Okay, so how do we obtain that? We can do a trick by multiplying both in the numerator, or like by multiplying and dividing by a number that would not change the equivalence. So if we multiply by x and divide by x, it won't change anything. However, it would permit us to get x here in the power. Let me explain it. So limit, this is equal to limit as h approaches 0, x times ln 1 plus h over x to the power of 1 over h divided by x. Let me clear the area above. So this becomes limit as h approaches 0. X can be elevated to the power. So you end up with ln 1 plus h over x to the power of x divided by h, right, divided by x. All of that becomes e, the number e, exponential. So it is equal to ln e divided by x. What is ln e? It is 1. Hence, it is equal to 1 over x, which is where we derive the formula ln x, the derivative of ln x is equal to dx over x, which is the derivative of x over x, equal here 1 over x. Fx equal ln x squared plus 2. So it is the limit as h approaches 0, ln x squared, okay, becomes x plus h squared plus 2 minus ln x squared plus 2 divided by h equal limit h approaching 0, okay, of ln x 2 plus 2hx plus h squared plus 2 minus ln x squared plus 2 divided by h equal limit, okay, so it is ln x2 plus 2hx plus h squared plus 2 divided by, because it is ln a minus ln b, it's equal to ln a over b, x squared plus 2. This is here x squared plus 2. Okay. Divided by h, so, okay. Now, what can we do here? 1 over h, x plus h squared plus 2. So, we can, okay, let's divide it. Let's break it down into x squared plus 2, okay, equal ln x squared plus 2 divided by x squared plus 2 plus 2hx plus h squared divided by x squared plus 2 divided by h equal ln 1 plus 2hx plus h squared divided by x squared plus 2 divided by h. Let's remove the h from, okay, so, or let's rewrite it as ln. Of course, don't forget that it is the limit of all of that, but we don't want to repeat ourselves, so limit as h approaches 0, this notation, we will keep it to the end, or till the end. So it is 1 over h ln of 1 plus 2hx plus h squared divided by x squared plus 2 equal ln of all of that divided or to the power of 1 over h. Okay, we need to transform this 1 over h here into the inverse of this quantity. So 1 over h, we need to transform it into x squared plus 2 divided by 2hx plus h squared, right? So here's how we do it. We simply multiply that. Okay, we multiply the ln, the numerator and the denominator, by the same quantity. So x squared plus 2 divided by 2x plus h times ln 1 plus 2hx plus h squared divided by x squared plus 2 to the power of 1 over h, and we divide by the same value here, x squared plus 2 divided by 2x plus h. So this is removed to the numerator, and we end up with ln 1 plus 2hx plus h squared divided by x squared plus 2 to the power of x squared plus 2 divided by 2 xh plus h square. Okay, so this becomes E, right? This becomes the entire quantity here, because 1 plus something to the power of 1 over something, given that this power here is the inverse of the inside, this becomes E, or the exponential. So ln E is equal to 1, and we are left with x squared plus 2 divided by 2x plus h, right? In the denominator. So it is 1 over all of that. Hence, the answer is equal to, you flip it again, 2x divided by x squared plus 2. Which is, by the way, the formula ln u, derivative of ln u, is equal to du over u. That is the derivative of the inside, which is x squared plus 2 derivative, is 2x divided by u, which is x squared plus 2. Derivative of f of x is equal to e3x. So it is the limit e3 times x plus h minus e3x divided by h as h approaches 0. Now we need to establish a law in the limits concerning the exponential. Limit eu minus 1 divided by u as u approaches 0 is equal to 1. This is one of the identities, so to speak, concerning the exponential. So it is limit e3x plus 3h minus e3x divided by h. Now, ea plus b is equal to ea times eb. Okay? So when we add the exponent, we can multiply the different terms. Okay? So e to the power of a plus b is equal to e to the power of a times e to the power of b. Hence, it is limit as h approaches 0, e3x times e3h minus e3x divided by h as h approaches 0 equal limit as h approaches 0, and we can remove e3x as a common multiplier, e3x to the power of e3h minus 1 divided by h. Now, remember this formula, limit eu minus 1 divided by u as u approaches 0 is equal to 1. But the exponent of the exponential, okay, this u term here in the numerator should be the same in the denominator. So the power of e is 3h. We need to have 3 in the denominator, right? So we need to multiply by 3 so that we get 3h in the denominator, and also in the numerator, because we need to create a balance. Okay, so we cannot multiply only in the denominator. We multiply both in the numerator and the denominator so that the quantity won't change. So limit as h approaches 0, e3x times e3h minus 1, and we multiply by 3, so it is 3 e3x divided by 3h. And this here, which is the limit as h approaches 0 of e3h minus 1 divided by 3h, is equal to 1 if you consider u is equal to 3h, right? And by the way, u or yes, and h equal to u over 3. So if h is approaching 0, u will also approach 0. So it's the same thing. So this quantity becomes 1. Hence, we are left with 3e3x times 1 equal 3e3x. That would be the answer for the derivative. At the end, thank you for watching. I hope you enjoyed this video and it was beneficial for you. See you next time. Bye bye.